The shadowy and eternally hungry monsters inhabit the entire cosmos. They arise when giant stars explode in space. Black holes, as heavy as our planet, are the size of a ping-pong ball. They lack a surface, but their gravity is so intense that not even light can escape. Black holes also do not have physical boundaries like a membrane. The event horizon, the closest thing to a limit, is a threshold that, once crossed, does not allow return. For a star, encountering a black hole usually results in a luminous spectacle and its destruction. Only one star that astronomers know of survived an encounter with a black hole as massive as 400,000 suns. This happened in a galaxy about 250 million light-years from Earth. Astronomers with very powerful equipment observed X-ray explosions roaring in space every 9 hours. They suspected these were distress signals from a star trapped by a cosmic abyss. The star was an average red giant when it first met its neighbor. Getting too close, the hungry space monster could not resist and began to devour its visitor. After consuming the outer hydrogen layers, only the star's core remained. Finally, the unfortunate star became a white dwarf. But, for some reason, the giant space monster could not finish the meal and left it in its orbit for later. Since then, the white dwarf has been orbiting every 9 hours. It stays at a sufficient distance from the black hole to avoid being devoured. Its journey is not ideal. Due to gravity, its orbital path constantly turns, resembling a spirograph after 2 days. As the black hole continues to consume it, the star keeps losing mass and increasing in size, making its orbit increasingly peculiar. Scientists believe it could someday spiral away from its enemy and become a planet the size of Jupiter. But this might happen in 1 trillion years, 70 times longer than the universe has existed so far. In the Milky Way alone, there are hundreds of millions of black holes and many more in the rest of the universe. They can feed on stars and release them into other galaxies. Current telescopes might not be powerful enough to detect them. Most galaxies, including ours, have supermassive black holes at the center, with masses of up to billions of times that of the Sun. Others, only 3 times the mass of the Sun. The closest black hole to Earth was discovered 1,000 light-years away, a short distance in galactic terms. It is in a star system visible to the naked eye. Scientists discovered it when they noticed a star behaving strangely, spinning frenetically. They concluded it must have a powerful gravitational companion. The most voracious known black hole weighs up to 34 billion suns and is about 8,000 times larger than the one at the center of the Milky Way. It devours the equivalent of a sun each day. Sometimes, black holes even swallow other black holes that come too close. Before embarking on a spacecraft to flee to a safe galaxy without black holes, there is good news. Although they are supermassive, they do not have a radius large enough to destroy Earth. And although they are voracious, no black hole should come closer to our planet than the Sun in the time the universe has existed, multiplied by 10 billion. In the unlikely event that one of these monsters passes near Neptune, it could affect Earth's orbit, which would be problematic. In theory, anything can become a black hole. The difference between these and the Sun is the material they are made of. Their cores are incredibly dense. To form a black hole, the gravitational collapse of a supermassive star 20 to 30 times the mass of the Sun is necessary. Therefore, the Sun will never become a black hole. If it did and maintained its mass, its gravitational power would remain the same. Earth would continue orbiting it, but without sunlight. In reality, the Sun is not massive enough for such a transformation and will eventually become a white dwarf. A black hole will never devour an entire galaxy. The Milky Way has about 400 billion stars, and only 0.1% will become black holes. The supermassive monster at the center of a galaxy has an impressive gravitational reach, but not enough to devour all the stars. It has already consumed most of the nearby ones and weighs about a few million suns, limiting its growth. Although galaxies will continue to collide and black holes will continue to merge, these collisions will not last forever. Eventually, black holes will travel through vast space without being able to devour dark matter or the outskirts of galaxies. Eventually, all black holes will perish, but that will be in a very, very long time. If you ever become a space explorer and encounter a black hole, your life will not end instantly. The perception of space and time will change, and your reality will split in two. In one, you will cease to exist. In the other, you will enter the hole unscathed. As you delve deeper, space will become more curved, reaching the singularity at the center, where the laws of physics do not apply. In a large enough hole, millions of times more massive than the sun, you would keep falling without feeling gravity until reaching the singularity. You could not move in the opposite direction. There, space and time exchange roles. In a smaller hole, gravity would be stronger in your feet than in your head, stretching you like spaghetti. If your travel companion does not fall into the hole, they would see you stretch and move in slow motion until you freeze, surrounded by flames. You would be in two places at the same time, but only one copy of you would remain. Black holes teach us that reality can be different for different people. Some scientists believe we all live inside a black hole. The universe began with the Big Bang, but there might have been a superdense seed containing all the mass and energy of the universe before. This seed could have been born inside a black hole. If you believe in multiple universes, black holes could be doors between them, like a root shared by two trees. You cannot see a black hole directly, only detect its effects on the surroundings. More than 200 scientists collaborated to take the first photos of this space rarity, using a telescope with the combined power of the size of Earth. Black holes are fascinating mysteries of the universe, forming when massive stars explode and collapse. These objects, which can be as small as a ping-pong ball but with the mass of the Earth, have such powerful gravity that light cannot escape. Although they do not have surfaces, their overwhelming gravitational pull creates an event horizon, a point of no return. When stars approach a black hole, they are destroyed in light shows. An exceptional case is a star that survived a black hole with the mass of 400,000 suns in a galaxy 250 million light-years away. Astronomers observed bursts of X-rays every 9 hours, interpreted as signals from a trapped star. This star, a red giant, was partially devoured, leaving a core that became a white dwarf, orbiting every 9 hours. In the Milky Way, there are millions of black holes and even more in the universe. They can consume stars and expel them into other galaxies, but current telescopes might not be able to detect them all. Galaxies usually have supermassive black holes at the center, some with masses of billions of suns. Others are comparatively small, with only 3 times the mass of the Sun. The closest black hole to Earth is 1,000 light-years away, in a star system visible to the naked eye. It was discovered by observing a star behaving unusually. The most massive black holes can weigh up to 34 billion suns and devour the equivalent of a sun each day. Some even absorb other black holes. Although black holes are massive and voracious, they do not pose a direct threat to Earth. None should come closer to us than the Sun in the time the universe has existed, multiplied by 10 billion. In the unlikely event that one passes near Neptune, it could affect Earth's orbit. Any star with enough mass can become a black hole. The difference between a black hole and the Sun is the density of its core. Black holes form from the gravitational collapse of stars.